this question. We've already expanded 2 plus x all to the power 5, and we're going to look at using that result to expand this rather strange expression here. Now, instinctively, we might decide to substitute this for x. Now, that'd be a mistake, because what's going to happen is when we expand that, the various powers of that are going to be little expansions in themselves. If you're very good at doing maths in your head and visualizing things, you might spot which powers are which, but that's going to be tough. So we're going to do the more sensible way and spot that this whole thing is actually a quadratic that expands rather nicely. So let's look at that. Turn it into a way more easily identifiable as a quadratic expression and quickly factorize it. Again, this is sort of an expert solution, so I'm assuming that you can actually spot this yourselves. There we go. And you'll notice one of these is y plus 2, and of course we've expanded 2 plus x up here. So turning it around, what we've got, and of course splitting the powers, one of these expansions is actually the one we've done already, and so it's a product of these two expansions. All we need to do is expand the other one then and find out which terms multiply appropriately. So let's have a look. It's a rather easy one to expand. We've already got our coefficients. We already worked them out previously from our Pascal's triangle. Should be on another page, but I'll write them out again for you. So there's 1, 5, 10, 10, 5 and 1. Those are our binomial coefficients for, in other words, our NCRs for n equals 5. So the nice thing here is because we're expanding 1 plus y to the power 5, it means that the first term is always going to be 1, because you're going to have 1 to the power 5 times y to the 0 times the coefficient 1. Second term is going to be 5 times, it's very nice, y will just, all the powers of 1 will stay 1, and y will just take increasing powers, and we can just use the binomial coefficients. So we can expand this very quickly indeed. And this happens because, like I say, a is 1, and y has no numbers in front of it, so no coefficients of its own inside the brackets. So it just expands out quite nicely into, and we probably don't even need to write the 1 there, but for completeness we've done so. There's the full expansion. Now, we need to decide how this relates to the other expansion, and when we multiply them, which terms are going to give us y cubed or x cubed. So easiest way to do this is probably lay the expansions next to each other in a reversed fashion, matching up the powers. So the cube here, y cubed, what would we need to multiply that by to stay with the y cubed? Well, a unit. So if we look at the units from the other expansion, start with 32. So you've got 32 here, and we write the expansion backwards. So here we now use 80x, but that, of course, in our case is now 80y, because we're expanding 2 plus y, not 2 plus x. So you've got 80y, and again, what we've got is y squared, and y will make y cubed. Okay, carrying on writing this expression up here backwards, we've got an 80y squared, and again, we've got a y and a y squared that will make the y cubed, and the next one will be 40y cubed. Beyond that, we're going to get powers of 4, so we're only really interested in the product of these 4 pairs of coefficients from both sequences. So, writing them out in full, we've got 1 times 40, so we've got 40y cubed here, and we've got 5 times 80 will be 400y cubed, and we'll have, we don't actually need to write the y cubes here, but for completeness, so someone can see our method, we'll do so. And we've got 800 y cubed, and in this case, we've now got 320 y cubed. Totaling up all the coefficients of y cubed here, we will have 40 plus 400 is 440, so that's 1240. 1560 will be the coefficient of y cubed. job done. Like I say, not a tutorial for the binomial sequence, but a way to do it rather quickly if you're familiar.